AI is changing new product development engineering forever. Welcome everyone. I'm thrilled to share how AI is transforming product development engineering and delivering exponentially more value through enhanced capabilities and workflows. The engineering landscape is experiencing a profound transformation. According to McKinsey, AI adoption in engineering is expected to grow by 25% annually through 2027. So this isn't just another tech trend, it's fundamentally reshaping how we approach product creation. Today, we're going to get into how AI is empowering engineers to conceptualize, design, test, and iterate with unprecedented efficiency and insight. We're going to look at the tools, workflows, and mindsets that separate leading innovators from all the rest, with special attention to perhaps the most overlooked aspect of engineering excellence, knowledge management. So let's get into it. The AI-enhanced product development landscape. Let's start by understanding where we are today in the AI-enhanced product development landscape. AI has already infiltrated key stages of the engineering process. Generative design tools create optimized structures that human engineers might never conceive. Simulation tools compress weeks of testing into hours. Requirements analysis systems can extract insights from mountains of user feedback almost instantly. Let's look at an example. Automotive manufacturers using generative design have reduced component weight by 40% while maintaining structural integrity and cutting development time in half. This isn't an incremental improvement. It's fundamentally changing what's possible within timeline and budget constraints. And by the way, you can always check the notes of this video to see the links to the peer-reviewed publications where all of my statistics are from. According to an IEEE engineering survey, only 23% of engineers report high proficiency with AI tools. So this means we have a major challenge, but also an opportunity. Those who embrace these technologies now aren't just getting ahead, they're redefining what's possible in their field. What I get really excited about, I think what we all should be excited about too, is the democratization effect. Tools that once required massive compute and specialized expertise, they're now accessible to independent engineers and smaller teams. I recently saw a 3-person startup leverage cloud-based generative design to compete against companies with engineering teams 10 times their size. And they won the bid because their AI-optimized design outperformed everybody else's. However, there's a critical bottleneck that even the most advanced AI tools can't overcome on their own, and this is the knowledge management problem. On average, 20 to 30% of R&D time is spent on documentation instead of innovation, and 46% of product development delays stem from inaccessible knowledge. When teams can't access past learnings, they repeat mistakes and miss opportunities. Core AI capabilities for engineers. So with these challenges in mind, let's look at some of the core generative technologies for the 10x product development engineer. Generative design systems. Generative design represents a fundamental shift in our approach. Instead of traditional cycles of design, analyze, improve, we now define constraints and goals, then let AI explore thousands of possible solutions, all simultaneously. These types of systems use machine learning to optimize against multiple variables that would be impossible for humans to balance manually. Let's turn to aerospace engineering for a perfect case study. They've used generative design to reimagine aircraft components, resulting in parts that are 45% lighter while actually stronger. The engineer's role shifts in these moments from drawing designs to defining the problem correctly and curating AI-generated solutions, then evaluating them. So when you're taking a look at which generative design tools to use, you should look for solutions with the following characteristics. They have to be able to integrate with your existing CAD systems. Allow for constraint-based optimization. Provide explainable results so you understand why designs look the way they do. And enable smooth transition from AI-generated concepts to more detailed engineering plans. Now let's look at simulation and testing acceleration. Traditional simulation methods like finite element analysis and computational fluid dynamics have always been powerful but painfully slow. AI is changing that equation dramatically. Physics-informed neural networks can now predict fluid dynamics results in minutes rather than the days required for traditional CFD. What's remarkable is how these tools are becoming accessible to non-specialists. You no longer need a PhD in computational modeling to run sophisticated simulations. I've seen mechanical engineers with no prior CFD experience using AI-assisted tools to optimize airflow designs that previously would have required specialized consultants. So when looking at simulation acceleration tools, you should prioritize those that use hybrid approaches, combining traditional physics with AI, provide uncertainty quantification to understand result confidence, allow for parameter exploration and sensitivity analysis, and of course, integrate with your physical testing workflows. Where else can AI make a huge impact? Automated documentation and knowledge management. Documentation has traditionally been engineering's necessary evil. Vital but tedious. AI is transforming this burden into an automated process. It can generate comprehensive technical documentation directly from CAD models, code, and simulations. The best knowledge management solutions can reduce documentation time by up to 70%. So instead of spending hours creating detailed specification reports, these systems can capture your design decisions as you make them, automatically generating the documentation that you need. Even more valuable is the automatic capture of the rationale behind your designs. How many times have you looked at a design from 6 months ago and wondered, why did we make that decision? Effective AI systems preserve this context automatically. They create institutional memory that maintains the why behind each of those critical decisions. So when you're looking for knowledge management solutions, look for capabilities that capture your knowledge automatically during the design process. Ones that offer natural language search across all of your documentation and connect insights across different product lines and projects. And of course, it has to integrate seamlessly with your existing tools and workflows. Now let's get into requirements engineering capabilities, because requirements engineering is being transformed by large language models. They can extract structured requirements from unstructured data, like customer interviews, competitor products, and market reports. Advanced systems analyze thousands of pages of documentation and look for patterns, contradictions, and gaps that human analysts might miss. One engineering team I worked with reduced their requirements analysis phase from 3 weeks to 3 days using these tools, while they actually improved the quality and completeness of their requirements docs. So as you evaluate AI solutions for requirements engineering, you should prioritize tools that handle multiple data formats and sources, identify conflicts and ambiguities automatically, link requirements directly to design elements, and maintain traceability through the development process. So what does the AI-augmented engineer actually look like? Now that we've covered the tools, let's explore how they fit into a cohesive workflow that turns a good engineer into a powerhouse engineer. I love thinking of this based on the moments of our day. So let's start with ideation and concept development. A lot of people worry that AI is replacing human creativity, but I think it's the complete opposite. It is amplifying it. Image generation tools are revolutionizing how quickly we can visualize concepts. I recently worked with a team that used AI to explore 50 different product form factors in a single afternoon, a process that would have taken weeks with traditional sketching and modeling. I think the key is we have to maintain our human creative spark as we're using AI to expand the possibility space, the art of the possible. The best engineers don't ask AI to go design a product. They think of the right thoughtful constraints, and then they use AI to explore variations that they maybe couldn't have considered or didn't have time to. How about cross-functional collaboration? This is one of the biggest challenges in product development, the need for engineering to communicate well with marketing, insights, with regulatory, with R&D. Marketing doesn't speak engineering, manufacturing doesn't speak design, and customers speak a whole language of their own. AI can now serve as a translator between all the worlds and people that you have to touch, connecting your engineering data directly to operations and creating a common language that all stakeholders can understand. Let me share an example. One medical device company I consulted with recently reduced their design iteration cycles by 40% simply by implementing AI tools that took engineering constraints and translated them for clinical advisors. That put the advisors in an amazing position where they can more meaningfully respond to the scope of the engineering requirements. The data here is really compelling. Teams using AI collaboration tools see 35% faster speed to market. And it's not just about efficiency. This is about building better products by ensuring all the perspectives are truly integrated into our design processes, which make us as engineers far more effective. How about prototyping and testing? Of course, everybody's talking about digital twins, and they're enabling unprecedented acceleration. Digital twins are virtual replicas of physical products that update based on real-world data. These become exponentially more valuable when combined with AI predictive capabilities. Automotive companies famously use this approach to test autonomous driving features in simulation for millions of miles before they ever reach a physical vehicle. But this approach isn't just for huge corporations. I've seen mid-market manufacturers use cloud-based AI simulation environments to validate hardware designs with virtual testing, drastically reducing prototype iterations and cutting dev costs by over 60%. So let's look at production and scale up. AI-driven design for manufacturing, DFM. These tools now can predict production challenges before they arise. Digital factory implementations have shown how designs can be tested virtually against actual production constraints. This ensures what engineering creates can actually be built efficiently at scale. I had the joy of working with household appliance manufacturer recently, and they integrated AI-based supply chain predictions directly into their design systems. This allowed their engineers to see in real time how material choices would affect production costs and delivery timelines, which led to designs that weren't just technically excellent, but optimized for market conditions and success. So all of this sounds great, right? If you're feeling what I'm saying, if you are vibing with this and it resonates, take a minute to leave a comment and share what mattered most to you. Hit the like button and share this with an innovation friend or an engineer who you know has their eyes set on 10xing their capabilities. And all that in mind, let's get into implementing this. How can you build an AI engineering strategy for your company and for yourself? Let's create a practical roadmap here. Start by assessing your specific domain needs. AI tools for aerospace are going to differ from those for consumer electronics or med device. Begin with identifying your highest value, most time-consuming tasks. These typically offer the best return on investment for AI implementations. Integration here is crucial. The most powerful AI engineering stacks connect seamlessly across platforms. So look for tools with robust APIs that can talk to your existing CAD, PLM, and project management systems. For documentation workflows, you should prioritize systems where documentation happens continuously alongside design, not as a separate or secondary task at the end. The key is creating a system where knowledge capture is automatic and retrieval from you is effortless. So when you're building your collaboration stack, make sure you prioritize tools that translate technical information appropriately for different stakeholders. This will allow you to communicate effectively with technical and non-technical colleagues so you can collaboratively solve problems. Of course, I want to share a little bit about Narratize and how it works to support all of these capabilities. Narratize has an incredible and powerful feature called the Product Knowledge Hub. It's a purpose-built solution for product development teams who need to move fast and make informed decisions. Narratize Product Knowledge Hubs transform how organizations capture, share, and leverage your product knowledge across the entire development lifecycle. This isn't just another document repository or collaboration tool. It's a comprehensive system designed specifically for the challenges of modern product development engineering teams. Here are some of the things it unlocks for you. Smart conversational AI that goes beyond typical interactions and continually refines your understanding of your product by absorbing every nuance, whether technical details or marketing insights. It proactively asks you the right questions at the right moments and it then ensures that every conversation deepens your team's understanding. It also supports dynamic document creation. It generates documents during your innovation process in minutes, not days. So it taps directly into the essential product insights that have been gathered by the system and then instantly produces hundreds of document types, from product requirements and tech specs to compliance reports. It also features company knowledge hubs that standardize how the AI generates the rhetoric of your organization. So these features weave in key company facts with product level details and create a single source of truth. As your team contributes and evolves, so does this repository, ensuring that institutional expertise is preserved and continuously enriched. Finally, the seamless integration builder that connects the essential knowledge bank to internal systems and, of course, third-party applications. By embedding your data securely and directly into everyday workflows, you can ensure that critical insights flow seamlessly across platforms. Predictive analytics for informed decision-making. This helps you analyze historic trends and gain access to real-time data that forecast which of your product development efforts are most likely to succeed and secure funding. With these insights, you can prioritize initiatives that promise the maximum market impact. The business results here are pretty remarkable. 46% faster progression through development cycles, 9 hours saved per person per week on documentation, 3 times improvement in documentation quality and compliance, and faster innovation cycles and time to market, which means improved product market fit. As one engineer recently told me, the Narratize Product Knowledge Hub paid for itself in the first quarter just from the time savings. The strategic value of preserving and leveraging our collective knowledge, it's priceless. So let's talk ethics and the future outlook of AI in new product development engineering. I want to address the ethical dimensions of AI in engineering. With great power comes great responsibility, and AI tools amplify both our capabilities and our potential impact. Bias in AI systems remains a concern. When training generative design systems, we must ensure we're not encoding historical design biases that could limit innovation or perpetuate problematic approaches. So it's critical to regularly audit AI outputs against diverse criteria. Transparency is another crucial consideration. As engineers, we must understand the limits of our AI tools and communicate them clearly to stakeholders. A 10x engineer isn't just technically proficient, they're also ethically grounded and honest about what their tools can and can't do. Choosing solutions that verify sources and enable traceability is key to supporting you with this. And finally, the human element is unreplaceable. As we continue to optimize within constraints, AI can support us in solving the right problems and remaining empathetic for our users, using creative insights and ethical judgments that make us as engineers far more valuable than any algorithm. For your career growth, positioning yourself as an AI-powered engineer rather than competing directly with AI is the most sustainable path forward. The engineers who thrive will be those who become experts at directing AI tools, defining problems clearly, and integrating diverse perspectives into the development process. Cross-functional collaboration is everything for innovation, and AI can help. So, how do you get started? Audit your workflows and identify high-value AI integration opportunities. Evaluate knowledge management solutions like Narratize that can transform your documentation process. Start small with a pilot project, demonstrate value, and prepare for scale. The future belongs to engineers who view AI not as a threat, but as the most powerful tool humanity has created yet. By creating these technologies thoughtfully, you truly can become a 10x product development engineer, delivering more value, creating better products, and finding more meaning in your work than ever before. Thank you so much for joining me today. I'm excited to see what you'll create. Make sure that you take time to share this with another engineer, and until the next time, keep innovating.